Hello, happy St. Patrick's Day of the coronavirus. Um, Yesterday, Squirrel and I did a very good job of social distancing, better than Sunday. Piedmont did come by and we did take a walk almost around the block. Squirrel was very unhappy with that. She thought that it was absolutely ridiculous, and as social distancing, we should not be talking to our friends unless it is via technology. So she was very, very angry with me. But I washed my hands and I told her that it was going to be okay. So, we're going to start this wonderful extravaganza with talking about what our plan is for this week. It just came to my attention that you don't know what the plan is because you can't see the board in my classroom. I know, Squirrel. They can't see the board. They need to know what we're going to do this week. Yeah. So, yesterday we did Transformations 1. Today, we're going to do Transformations 2. Yes, it's going to be including the calculator again. I know some of them don't have the calculator, Squirrel. It's okay. They can watch me do it on the calculator. I know it's not as good. It'll be okay. All right. Wednesday, then, we're just going to have some regular notes. And we are going to be learning about what happens when there is no calculator available. So there's sometimes that the Regents puts questions on there where you can't use your calculator. So we're going to be talking about that. Thursday, we're going to have a little bit of a quiz. Don't worry, I will explain the rules of the quiz and how to do the quiz online and all of that. You do not need to worry. Everything will be fine. And then Friday, we're actually going to take a look at those calculators and how to get your calculators. Because as Squirrel said, some of you don't have your calculators, and you really need your calculators for next week's lessons. For this week's lessons, you can just watch me do it, and that will be fine. But for next week's lessons, you need to be on the calculator. So we're going to deal with that stuff on Friday. I'm going to teach you how to get a calculator on your computer or tablet. And it will be the type of calculator that we have at school, so it'll all be good. All right. Now that we have talked about our mission for this week, let's take a look at the homework that y'all were supposed to do. Some of you had issues, mostly because you don't have the calculator. So let's take a look at the first one. Now, Squirrel, can you tell me what the first one is? Yeah, you can. What is it? It's an absolute value graph, yes. If you take a look, yep, those symbols mean the absolute value. So because those symbols mean the absolute value graph, we need to be taking a look at a V shape. So our original graph looks like this. Yeah? You see how our original graph looks, squirrely squirrel? Now, this is what's changing, and it's changing inside. Because it's changing inside, that's how we know that B is changing. It's positive, which means which way is it going to go, squirrel? No, that's not right. It is not going in the positive direction. That's the sad part. It has to go in the negative direction because B is always flipped of what you would think it is. So we're going to march it 5 spots this way. And it's going to look approximately like this. Now, always notice there are 3 rules when we're graphing. Squirrel, do you know what the 3 rules of graphing are? No, you don't? Well, I'll tell you. The 3 rules of graphing are that you need to go all the way to the end, you need arrows, and of course you need your labels. So this is going to be y equals absolute value of x. This is going to be y equals absolute value of x plus 5. And of course, the difference between the 2 graphs and why did it happen? The difference between the 2 graphs are y equals absolute value of x plus 5 is not if, is 5 units left because b changed. All right, now I'm going to quickly do 2, 3, and 4, and then we're going to talk about what they should look like. And look at that, magic. It's done. So if you take a look, we started with a regular parabola. The parabola went up 5. It went up 5 because if you notice, this should be a parentheses around the x squared. And the 5 is not in the parentheses. The 5 is outside the parentheses. That means that C is changing. C means up and down. And in this case, it's going up. So the difference between the two graphs, y equals x squared plus 5 is 5 units up. Yeah, 5 units up. Notice, squirrel, that because the thing is not in the 5 is not in the parentheses, it's going up and down. It's not going side to side anymore. All right. For this one, the 5 is in the parentheses, and now we've got a minus 5. Now, just like I told Squirrel before, it's a minus 5. We do not go minus 5. We have to go plus 5. That is extremely confusing, isn't it, Squirrel? I know. It's cruel. But that's what happens. Whenever B changes, it goes the opposite direction of the way you think it should go. So what is the difference between the two graphs? The y equals parentheses x minus 5 cubed is 5 to the right. And then this guy, the 5 is outside, but it's not added or subtracted or anything. In this case, what is happening, it's changing our slope. So instead of going up 1 over 1, like our original square root graph, it's going up 5 over 1. That's what makes it look like it got skinnier. So what's the difference between the two graphs? Slope of y equals 5x is steeper. Steeper? I think that's how we spell steeper. School, do you know how to spell steeper? She just goes, no. Okay. So that is because the A is changing. Yeah, the A is at the front of the equation. Let's take a look at the back. Now, the back was particularly difficult if you did not have a calculator. Let's take a look at it. This one is obviously an absolute value graph. You see the absolute value signs, and you see the beautiful classic V pattern. The slope up 1 over 1, so we must have been doing a 1 there. Have we moved it side to side at all? This would be A, this would be, sorry, this is A, this is B, and this is C. B controls our side to side pattern. It's normally at 0, 0. We have not gone anywhere side to side, so that's going to be a 0 right there. And C, we have gone down, so it needs to be a negative, and we have gone down 9 units. Yep, that's how you fill in the blanks. So let's take a look at the second one. The second one, beautiful classic parabola. We've got the squared there. Our slope up 1 over 1, so we must be going 1. And we're normally at 0, 0. Have we gone up or down? No, we have not gone up or down, but we have gone side to side. Now, this was the tricky part, Squirrel. Do you remember being scared of this one? I think she's asleep now. That's unfortunate. Okay, this one we are going to the left. Because we're going to the left, we're going positive, how many units? 1, 2, 3, 4, 5, 6 units. So we're going to keep that plus sign there, and it's going to be 6. Okay, let's take a look at 7. 7 is our beautiful serpentine cubic function, normally starting at 0, 0. We're going up 1 over 1, so 1 it is. What about the movement? Now, we have moved forward and backward, we've moved up, we've moved down, crazy stuff has happened. We are now at this point. Our 0, 0 has moved to this point. So, we have basically moved this way how many units? We've moved this way 6 units. This is at 6 over here. So, we have moved -6. Yes, squirrel. You remember it's negative. Why is it negative? Because the x goes the opposite way of the way you think it is. You're so good at this. Yes, you are. You're such a fast learner. Okay, and it has gone up 1, so we can put the positive 1 there. And for the last one, we've got a beautiful square root function, always starting at 0, 0. We go up 2 over 1. So that would be 2 over 1 there. And then we are going in this direction 3 units. We are not going up or down, so that can be a 0. That direction, notice, that direction is going to be a plus 3 units. All right, that is how the homework should have worked. We're going to talk about that a little bit more, but for right now, what we're going to do is we're going to go on to the next set of notes, and we're going to take a look at what happens if you can't plug it into your calculator. Because we're going to start moving towards that, you can't plug it into your calculator, what do you do? All right, to the notes. So we are on Transformations 2. In your calculator, for those of you who have your calculator, who have the program, and whose calculators are charged, you can follow along. For those of you who don't, you're just going to watch me. So, yes, squirrel, you don't have a calculator. So you're going to have to watch me. Okay. Yes, you can go to the bathroom. She's going to litter box right now. Okay. So, let's take a look at the transformations of graphs. First thing we've got is our favorite exponential graph. Now, exponential graph is the one that, yeah, that's our zombie problem. That's what we're living right now, yes. One person has corona. If they are in the vicinity of another person, then 2 people get corona. The next day, those 2 people go out, and they're in the vicinity of people, so then 4 people get corona. I know, it escalates very quickly. That's why we have to do the social distancing. Okay, so let's take a look at exponential graphs and what happens when we start moving the sliders. So B slider, let's take a look at our B slider. B slider, if you remember, if we move it this way, what happens to it? It has to move the opposite direction. And if I move it this way, it moves the opposite direction. For our C slider, goes up, goes down, and then let's take a look at our A slider. Now, for our A slider, this is going to control the slope. This is why we are doing our social distancing, squirrel. This is because if we were to go to school, look at how fast that changes. Look at how steep that curve is. Yeah, because Izzo comes into contact with a lot of children every day. Yes, and so one Izzo spreading corona would go crazy. Yeah, I do not have corona, don't worry, squirrel. And I want to keep it that way. So one student spreading corona, we do not want to escalate quickly. So what we're doing is we are trying to extend it, go a little bit like that. So it starts really slowly and escalates. It still escalates, but it doesn't do it as painfully. And then, of course, not in real life, but in math life, we could flip the graph, just for fun. All right, we're going to put that back to 1. Once again, Izzo does not have corona, and she wants to keep it that way. All right, so the B slider moves it left and right, but in the opposite direction of you would think. What happens to the C slider? Up and down. And what happens to the A slider? That controls our slope. Now the B slider would be inside the parentheses, or in this case, do we have parentheses? No, it's up in our exponent. C slider is then a real number outside of the exponent. It's out on the ground. And our A slider, that's out in front. Okay, let's take a look at the next one. Next one does not look like anything we've ever seen before. This is called a piecewise function, and next week we're going to be learning how to graph piecewise functions. Now, we do not have an equation, so we can't graph this on the calculator. That's what's going to happen on the Regents. The Regents is going to give us a picture, and it's going to look absolutely crazy. Or sometimes they don't even give us a picture at all. They just give us f of x. If they just give us f of x and then start changing numbers in the formula, we have to know what they're doing. So sometimes they'll change the B slider. If they change the B slider, that means that we're changing left to right. So if they have f of x and f of x minus 3 in the parentheses, they're changing the B slider, and that means they've gone to the right direction. They've gone right. Sometimes they will change our C slider. If they change our C slider, make it go this way or go this way, they're changing the number on the outside and they're going up and down. And sometimes, although very rarely in Algebra 1, most of the time they save this for Algebra 2, they will change the slope. Now, if you notice, they could make it thinner, they could make it fatter, or they could flip it. And that's what the negative would do. So let's put this back at 1, and let's take a look. B slider is left and right in the opposite direction, up and down in the correct direction, and our slope. So this happens for all of the graphs that we've been talking about, all of the graphs that we've done so far. It also happens for completely random graphs if they just call it f of x. Now let's take a look at this guy. This guy is g of x. He's cute. He's just a random g of x. It's not actually g of x. This is actually a very particular graph that you will learn about in Algebra 2. It's got a very special name to it, but right now we're just going to call it g of x. What happens with g of x is we've got all these sliders going on. And let's take a look at what these sliders mean. We've got this one, we've got this one, and we've got this one. The 2 is my a, that's going to be the slope. This is my b, that's going to be right or left. Well, it's positive, so it's got to go this direction, just because. And then this is my c, and it is negative, so we are going down. So what we're going to do is we are going to take the original, and we're going to graph that original. Start with graphing the original, always start that. And we do, okay, that's at 0, 0, 0. It goes up and it goes down. So up 2, down 2, down to, up to, up to. And we're just going to do this beautiful little wave. These are the waves that actually keep track of tides and of all those cycles, like moon cycles. Like we had a full moon last week. So that's what the original looks like. What we're going to do is we're going to have to build onto that to get the new one. Our slope is up 2 over 1. So we are going to basically double what's happening here. Here we've got 1, and it's going to be doubled, so now we're up at 2. Here we've got 0, so the 0 isn't going to change any. Here we've got -1. Doubling that, it becomes -2. So we're just going to start doubling it to make it look a little bit thinner. If we take a look at our graph, taking A, making it 2, hopefully, if it likes me. There we go. No! I had it! 2, oh well, close enough. 2 looks like that. Yes? Now what we're going to have to do is we're going to have to deal with the B. The B slides it which way? Well, I want a +3 there. So we are going to go 3 in this direction. So that means we go 3 this way. So this point goes 3 this way. This point goes 3 this way. And we're going to do everything 3 that way. So it's going to start looking a little bit complicated. What I want to do, as soon as you move a point, we're going to erase it. So that I've erased. That guy I've erased now. This guy needs to go 3 this way. This guy needs to go 3 this way. And this guy needs to go 3 this way. This guy right here needs to go 3 this way, and then erase him. Erase the blue, since we've already done the blue. This needs to go 3 this way, erase him. This guy needs to go 3 this way, and erase him. And then those guys would be off the chart. So now we have this. This should be up. Nope. Like that. And then what we need to do is we need to drag this guy over to -1, which means everybody has to move down 1. So I move everybody down 1, and we get something that looks like this. So what did we have to do to the original graph? Slope changed to 2. Then we had the red where we went 3 units to the left, and then 1 unit down. So that's what it should look like. Now I'm going to turn everything back to where it was. So we're going to go back to 1. We're going to go back to 0. And we're going to take this guy and go back to 0. Now let's take a look at the next one. I know that was very confusing. The more you do this, the better it will be. So let's take a look at this guy. This is H, and we're going to find H. There's H. That's not H. One moment. The picture is wrong. Ignore this picture. Silly picture. Okay, so we've got H. It's beautiful. We're going to do negative H plus 3. So in order to do negative H plus 3, this guy has to be our slope. That's A. Notice, where's our B? Our B's not there. So B has to equal 0. So we're not going to touch our B. If there is no B, don't touch it. And then this is C. C is 3. So we're probably going to be going up 3. So A, we go negative 1, because we always imagine a negative. And then C, we have to go 3 that way. So if you look at this, I had actually already done the negative 1 there. Why it doesn't show as a negative 1, I'm not sure. So this is what it's going to look like now. I'm going to do a quick sketch of it. It's going up 3 and up 1. Nope. It's up 3 and then up 2 over 1. That's a strange graph. It goes like this, and it goes like that. Weirdo. What did we do to the original graph? We flipped it and moved it up 3. All right. Your homework is to take a look at just G and just H and see what you can do with it. So take a look at G and take a look at H and see if you can do what it says. Now, because H is in your calculator wrong, I do not want you to do 3 and 4. We're not going to do 3 and 4. We're just going to do 1 and 2. So you're going to take a look at G. So you're going to move these sliders back to 1 and move the slider back to 0. You're going to go back to G and you're going to fiddle around with G and see what you can do. See what the 3 would do. See what this negative 8 would do. Good luck.